Welcome to this session on AI risks related to bias and discrimination. I'm Janelle Thomkel, and I advise on the development of responsible AI at frontier labs like Anthropic and Google. As AI is increasingly deployed in high-stakes domains, it's critical for business leaders to understand and manage the risks posed by biased AI systems. So what exactly is bias? AI bias refers to systematic errors in AI decision-making processes that result in unfair outcomes. A concept related to bias is AI fairness. AI fairness is the study, detection, and advancement of equal treatment across groups defined by sensitive attributes in AI systems. These sensitive attributes include race, ethnicity, gender, sexual orientation, disability, and class. To explain this more concretely, here's an analogy. The human brain is a complex organ that functions through conscious and unconscious connections and makes implicit associations often outside of our control or even awareness. AI models, which are trained on substantial volumes of human-generated data, can end up reflecting the same explicit and implicit associations that our brains make. When AI systems are biased, they can discriminate against certain groups, posing significant risks for individuals and businesses. It is important to identify and address bias in AI to ensure that these systems are fair and equitable for everyone. So how does bias appear in AI? Sources of bias in AI can arise from different stages of the machine learning pipeline, including as a part of data collection, algorithmic design, and designer interactions. Training data bias occurs when the data used to train models is overrepresentative or underrepresentative of certain groups or is incomplete, leading to biased outputs. This can happen when the data is collected from biased sources or when the data is incomplete, missing important information, or contains errors. For example, training data for a facial recognition model that overrepresents lighter skin tones can result in errors when attempting facial recognition on darker skin tones. Algorithmic bias, on the other hand, occurs when the algorithms used in machine learning models inappropriately correlate variables with certain attributes. This can happen when algorithms are based on biased assumptions or when they use biased criteria to make decisions. For example, a model might use income or language as a proxy and unintentionally discriminate against people of a certain race or gender. Cognitive bias occurs when the people designing AI systems introduce their own biases or prejudices into the system, consciously or unconsciously. This can happen when designers provide biased training data or design the system in ways that reflect their own biases. For example, US developers might only use datasets gathered from Americans instead of sampling from a range of populations around the globe. One type of bias that often gets overlooked is inaccuracy within specific subgroups. For example, let's say you have a credit scoring model that overestimates risk for one population while underestimates it for another. This type of bias can lead to two main problems. First, it can cause pure business losses. If you're underestimating profitability for one target audience and overestimating it for another, you might misallocate capital and resources, leading to suboptimal business outcomes. Second, and perhaps more seriously, if the subgroups with inaccurate predictions relate to protected classes like race, gender, or age, you could be facing both business losses and legal risks. Discrimination, even if unintentional, can attract lawsuits and regulatory enforcement. Let's look at some real-world examples of bias across a variety of applications. An AI resume screening tool used by Amazon unfairly scored resumes from women lower than those from men. The company's models were trained to assess applicants by observing patterns in resumes submitted over a 10-year period. Most of these resumes came from men, given their predominance in the tech industry. As a result, the algorithm ranked resumes with the word women's, as in women's chess club captain, lower. Healthcare algorithms have also shown racial bias in predicting health needs. In 2019, a study found that an algorithm used by many hospitals to decide which patients needed care demonstrated racial bias. Black patients had to be deemed much sicker than white patients to be recommended for the same care. The model had been trained on historical data on healthcare spending, which reflected a history in which Black patients had less to spend on their healthcare compared to white patients due to long-standing wealth and income disparities. AI models used in criminal justice have also reflected bias. AI-powered predictive policing tools using historical arrest data were found to reinforce existing patterns of racial profiling and disproportionate targeting of minority communities. Generative AI technologies, like image generation models and large language models, can also reflect and amplify societal biases in concerning ways. Let's look at a couple of examples. In the image generation context, research by organizations studying AI bias has shown that image generation models tend to exaggerate feminine sexual characteristics when creating visuals of women. This bias likely creeps in from the training data, which may overrepresent objectifying or sexualized portrayals. Biases in these models can reinforce harmful stereotypes, enable the creation of non-consensual explicit imagery, and skew societal expectations around body image. But bias in generative AI isn't just a visual issue. Large language models can also exhibit clear gender and racial biases in the text they produce. For example, when prompted to write employee reviews, language models have been shown to generate more positive appraisals for men and more negative ones for women. They may associate leadership traits with male names while ascribing more supportive roles to female ones. If used in the real world without proper checks, biased language models could unfairly sway performance evaluations, reinforce occupational stereotypes, and normalize prejudiced language in business communications. While AI bias can occur in any domain, certain contexts carry particularly high risks. These are areas where biased AI could directly impact people's livelihoods, well-being, and fundamental rights. Let's explore some of these high-stakes scenarios. First, businesses need to be especially vigilant about AI bias in use cases that determine people's access to critical opportunities and resources. Think about AI systems used to make employment decisions, approve loans and credit, underwrite health insurance, allocate housing, or assess risk in criminal justice. Biased outcomes in these areas could unfairly exclude already marginalized groups from jobs, financing, healthcare, housing, and due process. Second, companies also need to pay special attention to domains where there is a history of discrimination or where certain groups have been underrepresented in the data used to train AI models. This often includes contexts involving race, gender, age, disability status, and other protected characteristics. Without proactive efforts to collect representative data and test for disparate impacts, AI risks perpetuating and even amplifying long-standing biases. Third, the risks of AI bias aren't confined to these traditionally regulated sectors. We might start to see greater scrutiny in other areas, like retail pricing. Imagine if a company used AI to offer different prices for consumer goods or telecom services based on a customer's race, gender, or other sensitive attributes. Even if not illegal, such practices can be deeply unethical and damaging to a brand's reputation. As AI becomes more prevalent in pricing and personalization, companies across sectors will need to be proactive in assessing and mitigating bias. So let's talk about responsibilities of various stakeholders, starting with developers. Developers should use representative training data, extensively test for biased outcomes, and provide transparency on system limitations and risks. Oftentimes, developers disclose this information, including model performance results on evaluation datasets geared toward specific applications, in model cards and developer documentation. Developers can also build in human oversight and avenues for appeals. Note that this is likely more relevant for developers of application-specific models and more challenging for general-purpose model providers, since designing in human oversight at the right moments is highly use-case specific. While developers have a key role to play, it's crucial to remember that deployers share responsibility for the ethical use of AI. In many cases, deployers are better positioned to understand the nuances and potential impacts of the specific context in which the AI is being applied. Deployers need to carefully assess whether an AI model is appropriate for their use case, given the model's known limitations and biases. They should consider the potential consequences of biased outputs in their specific domain and implement additional safeguards as needed. For example, companies deploying AI can do a number of things to detect and mitigate biases. First, they should carefully vet providers and review their bias mitigation practices. Again, look for model cards and other documentation demonstrating how models might perform for your intended application. Second, assess systems for bias before and during deployment. You don't want to launch a feature in your product only to discover unmitigated bias risks, causing you to pause or retract your feature. Conduct pre-deployment testing and consider gradual rollouts to detect biases that may not have been obvious under smaller scale conditions. Third, ensure meaningful human oversight, especially for high-stakes decisions. Consider building in moments for human review or approval before relying on model outputs or decision-making. Fourth, consider whether there's an opportunity to implement a clear appeals process for AI decisions. Finally, continuously monitor for bias and fairness issues. Ultimately, mitigating AI bias requires a shared sense of responsibility across the entire AI supply chain. Developers need to build models with fairness in mind from the start, while deployers need to thoughtfully adapt and oversee these models in their specific contexts. It's not a handoff from one to the other, but an ongoing collaboration. Developers and deployers need to maintain open lines of communication, sharing insights and best practices around bias prevention. And both need to be prepared to iterate and improve their processes as understanding of AI fairness evolves. There are a number of reasons why mitigating bias in AI is not a straightforward task. The complexity of modern AI models can make bias incredibly difficult to detect and address. As models become more sophisticated and training data more vast, the potential for subtle biases to creep in increases. One of the key challenges is the sheer scale of data involved. The more data you use to train an AI model, the harder it can be to identify problematic patterns through small-scale testing. Biases can hide in the complex interactions between thousands or even millions of data points. Another difficulty lies in the interconnected nature of AI model variables. Bias can emerge not just from obvious sources, but from subtle correlations and interactions between features. Attempting to adjust one variable to mitigate bias may inadvertently introduce new biases or negatively impact the model's performance in unexpected ways. Further, given the complexity and scale of the challenge, testing for every conceivable form of bias may be infeasible, especially for companies with limited resources. A more pragmatic approach is to identify the categories of bias that pose the highest risk for a given use case and prioritize efforts to detect and mitigate those. Fixing identified biases is not as simple as tweaking a few lines of code. It often requires carefully curating new training data, experimenting with different model architectures, and iteratively retraining and testing the model. This process demands significant technical expertise and computational resources. Moreover, efforts to mitigate bias can sometimes come at the cost of the model's overall performance. Companies need to be prepared to make difficult trade-offs between fairness and accuracy based on the specific requirements and risks of their use case. To navigate these trade-offs effectively, it's essential to have access to the right expertise. This could mean hiring in-house AI ethics specialists, partnering with research institutions, or engaging with third-party auditors to assess and validate bias mitigation efforts. Testing for bias in AI systems is crucial. Let's break down some key approaches. First, evaluate the AI system's performance metrics, like accuracy and recall, across different sensitive attribute groups. Compare these metrics between groups to identify potential biases. Consider using intersectional testing to reveal biases that may not be apparent when looking at single attributes. Second, use simulated data to stress test the AI system by creating synthetic data points that represent uncommon or edge case scenarios. Third, conduct regular audits of the entire AI pipeline, including training data, model outcomes, and human review processes. Fourth, engage domain experts with deep knowledge of the specific field to provide insights into potential sources and consequences of bias. The risks of biased AI are not just ethical, but also legal and reputational. Biased AI can result in misallocation of resourcing and capital, resulting in pure business losses. Biased systems could violate anti-discrimination laws and attract costly lawsuits or regulatory enforcement. Many states are introducing new laws specifically targeting bias and discrimination in AI systems. Additionally, federal regulators, such as the EEOC and the FTC, have identified AI bias as a key enforcement priority. Biased AI can have serious reputational consequences for companies. It can damage the brand, making it harder to attract customers and top talent. Most crucially, it can erode the trust that is essential for long-term success. Given the severe ethical, legal, and reputational risks, proactively addressing bias is a business imperative in the age of AI. To recap, don't wait until biased outcomes surface to address AI bias. Proactively assess the risks of bias before deploying any AI system. Ensure that the data used to train your AI models is representative of the population the system will serve. Continuously monitor the system's outputs for signs of bias even after deployment. Keep humans in the loop, particularly when AI is used for high-stakes decisions that significantly impact people's lives. Human oversight can catch biases that automated testing might miss. Implement a clear and accessible process for individuals to appeal AI-driven decisions. This is crucial for catching and correcting biased outcomes that slip through other safeguards. The field of AI bias mitigation is evolving rapidly. Make it a priority to stay current on the latest research, techniques, and regulatory developments. Building fair and unbiased AI systems requires a commitment from the highest levels of the organization. Leaders must set the tone by prioritizing the ethical use of AI and allocating the necessary resources to address bias. I'll leave you with these key questions to ask as you consider developing and deploying AI in your company. How are you ensuring AI fairness? Who is responsible for managing AI bias risks? What are your processes for testing, auditing, and appeals? How are you ensuring meaningful human oversight and staying current on best practices? How are you making principled trade-offs between accuracy, bias, and other considerations? By asking these critical questions and treating AI bias as a core business risk, you can maximize the benefits of AI while mitigating the downsides. Thank you for taking the time to learn more about this important issue.